presentation. It will be presented by Barbara, and it will be an independent evaluation of ChatGPT on mathematical world problems.
Thank you so much, Andreas. So, for those of you who don't know me, I'm a professor at Arizona State. And after I got my tenure, I took some time off to run a startup company that was using a supervised machine learning model we developed to predict which software vulnerabilities people would exploit. And so we had this machine learning model running on this server, and it would spit out results, and all the customers would use those results to make some really important decisions. And we had a dashboard that we used internally where we looked at metrics about how well the model was doing with its predictions when we had ground truth. And every time the metrics were a little off, that was a big fire drill for us. We had to see, what caused this. Was it the source data we were using to generate our features? Was it something about the distribution of the data for the whole problem that changed? Or was it an implementation error? And we came up with a bunch of ad hoc engineering solutions, but all that did was speed up our reaction time. We were never, ever ahead of the problem. And so after the company sold about a year ago, I came back to my day job, and I started thinking about problems of predicting the performance of ML models. And when ChatGPT came out, I had two really bright undergrads come to me saying, hey, we want to do something with this. And I saw for every tweet about ChatGPT doing something cool, there's a bunch of other tweets saying about how it's screwing something up. And I thought, wouldn't it be great if we could try to see if we can predict its performance? So that's what this challenge is all about. What we did is we collected data, so thanks to Abhinav here, who wrote the bots before OpenAI released their API that allowed us to collect data. Now we've moved to API. And then Noel here, who established some baselines and also showed that there's actually signal in the information that's provided where we can say some things about the performance of these word problems. So I'm going to go with you through those results really quick. And also toward the end, I'll show you where you can look at the challenge problem website as well as where our data set is posted. The nice thing about this challenge problem we wanted to do for the community is you don't have to pay to use ChatGPT or go through getting that data yourself. We've already done it, and also that makes it standardized so it's a more proper challenge problem. Okay. So I don't think, I don't think I need to say much more about why ChatGPT is significant. I think we can all agree on that. And then, but why study the performance of it? Well, in general, in addition to what I said about my experience with the startup, we can start to understand vulnerabilities in these models. Where are things that will cause it to fail? And yeah, there is all this work on adversarial ML out there, but I think what's going to happen with things like ChatGPT is you're going to start seeing people who are like penetration testers for machine learning models, and as opposed to relying on algorithms to identify how to make things go wrong, people are going to come up with new intuitions. And I think we saw a little bit of that with the recent stuff with AlphaGo as well. We also, of course, want to identify limitations. And then ideally, we want to be able to introspect a little bit and see, if we can predict the performance of something like ChatGPT, can we understand why? And then we know, hey, maybe I don't want to ask it those questions, or maybe I want to use a somewhat different prompt when asking it that question. So we use the Draw1K dataset, which is a rather challenging and standard data set of math word problems. There's 1,000 of them. In our paper, we identified some characteristics and we created this baseline model. And so as a warm-up, here's an example math word problem, very easy. One whole number is 3 times the second. If 20 is added to the smaller number, the result is 6 times the larger. So Anyone can go through this algebra and work through 2x equals 14, x equals 7, y equals 21. There are your two numbers. So let's see with this one what happened when we put it into ChatGPT. Here's me typing that in, and ChatGPT actually gets the math equations right, which is, this is a big accomplishment already, where it can get the math equations right from the text half the time. I think a couple of years ago, we probably would have had doubts about being able to do that. And it rearranges the equations, and here it's doing it right. And then it proceeds to screw up the algebra. You see it has 3y on one side and y on the other, and then there's only one y left. This should actually be a 2y. So, and then of course it gets the wrong answer. All right, so, okay, but what causes that, and how often does that occur? So first experiment we did early January, and this was the experiment we put in the abstract for our paper. So if you were one of the reviewers, this is what you saw. And so we had our 1,000-word problems, we had to write a bot because the API wasn't out yet, and we only took the answer. And there was a little bit, we were thinking kind of practically where we would get results faster, because when ChatGPT first came out, it was pretty slow because just millions of people were in it. And also we figured, well, if you're sending it a problem, all you care about is the answer. And we got absolutely miserable results, okay? This returns answers, but none are correct. This means there was nothing about the answer that we could have possibly gave it credit for, okay? If you're grading like a sixth grader, they would get an F, okay? You would have no mercy here. There's nothing you could do. So even with this extreme thing, you have 83% totally wrong, and 1% it just says nothing, and we know there's a solution to all these problems. They're in a data set. So this was like rather shocking. It's like, whoa, this thing's doing awful. And I'm not, I don't view myself as a ChatGPT hater. I was actually disappointed because I was worried, maybe we can't do anything with this. We just showed it didn't work. But then OpenAI said on January 30th, which is after our abstract got accepted, of course, that they improved their mathematical ability. So when we put together the final paper, we did a couple more experiments. So we went at it again, and experiment 2 is pretty much the exact same thing, just at a later time. And what do we get? Same thing. Okay? The numbers were a little bit different, and they were like, what's going on? Okay? And then what we thought was, hey, maybe there's something about telling it not to give us the answer, or not to give us the work, and just give us the answer that's messing it up. So let's change the prompt. So we do this again, and we put no additional text. We're like, just show us everything. And at this point, they had some performance improvements, so it didn't take as long. And we got way better results, okay? You got 51% of the time is like everything is totally right, okay? And then if you throw in another, 29% where it gets at least one of the answers right for multi-part solutions, essentially the results are flipped. And by the way, for Draw 1K, the state of the art is around 60% accuracy. So this is actually, about there. Depending on, how it's handling those partial answers. So this is much more encouraging. Now, what drives the failures? And is it the same thing in the old version with, bad prompt and this good version here? So we looked at a bunch of factors. What we have in this data set is we have the actual math problems in the ground truth. And so we could look at things like number of additions and subtractions, number of parens, number of unknowns in the actual solution. And we can use this as a measure of difficulty of the problem. And we looked at a lot of these factors. What we're showing here, you've got 95% confidence intervals. The dashed lines is the base failure rate, so that is just totally wrong or gives no solution. There's some difference here where you have multiplications and divisions seem to be a factor in the version that shows the work. Not so much in the February version, but also came up in the original. With all three, additions and subtractions seem to be significant. And after looking at these single variables, then we decided, well, let's see if there's any trend. And additions and subtractions, in the ground truth, there was a definite monotonic relationship between that and probability of failure. And so this was like quite striking. And the linear relationship, just to throw a model at it, is actually quite strong and seemed to get stronger with each experiment for some reason. My gut feeling is why the linear relationship may have gotten stronger is there's less noise and other stuff causing it to be wrong would be my supposition there. Where way over here, where you have really bad results, it's kind of conking out really quick. In this, I think the factor of additions and subtractions is being isolated. Now, as a guy who did his dissertation work on logic programming, I right away start thinking, well, hey, maybe it's struggling with inference steps. Okay, I don't, other than these empirical studies, I don't have any super hard evidence of that, but that seems to me to be a good hypothesis. So then what we decided to do, we thought, hey, let's take all these features, some of them seem to be predictive, let's see, throw them in a machine learning model and see if it can predict incorrect answers at some level better than guessing. And putting up kind of what the split is between incorrect and correct, in general, we're getting precision numbers that are above, this is precision of incorrect. So this model says it's incorrect and it's actually incorrect. Here with the random forest, the best we got for the February result with showing work is 78% for 69% recall. And considering only 20% of the samples are incorrect, that's actually quite good. So I don't think this is ready for prime time, so don't get me wrong here. I'm not like saying this is like, the greatest result, but what we're trying to establish here is a baseline for the challenge. And so I'll touch some things that are beyond the study that we've done since submitting the final version of this paper that were kind of cool, and we'll probably publish on these later, but I think just relevant for people interested in the challenge. So we did all this performance prediction using the ground truth equations. Now, operationally, you of course don't have that. If you had the ground truth equations, you wouldn't be using ChatGPT in the first place. But ChatGPT can give you what it thinks the equations are. And so can we use that for performance prediction? And then likewise, as kind of a side note, not really related to the challenge, we took prompts away and got better results. Can we add other things to the prompt and improve results? And so the first one I'll talk is the prompt addition result. And we actually seem to cut false positives from, or the false answers from 20% down to 10 by adding this little line here. Let's think things through step by step to get the right answer. And my students here who got this result, they came up with that prompt by asking ChatGPT questions about what it could add to the prompt to give a better answer. This is interesting here. Number of additions and subtractions on that same experiment and the effect of probability of failure. You still see the monotonic relationship. Notice here there is a lot more additions and subtractions than in the ground truth, which is interesting. So it seems to maybe come up with more complicated equations than is actually needed to solve the problem. There's also some little weird variance where it's not as crisp as the results on the ground truth were. But what's interesting is it wasn't just additions and subtractions. We also noticed stronger monotonic relationships for number of unknowns, number of parens, which we did not see with ground truth. And they also had weird little dips at different parts. And then when we tried to train the random forest model with it, we got results comparable to what I showed you for ground truth for precision and recall. So that was really interesting, that we think you can actually do performance prediction for word problems. So, we did our part to help get this set up. So now the challenge is on all of you. Can we predict ChatGPT errors on draw 1K? So I'm going to say the metric is precision on the incorrect class, on when it gets it wrong, when recall is 0.5, and then if people are maxing out that precision, then we'll look at recall. When ChatGPT was shown to be totally incorrect for our February data set where you have all the work. Okay, so that's where the baseline is 20%. And then our random forest model got 78%. We also, in our data set, we've included ChatGPT's actual responses. So you have in that data set, you have what ChatGPT actually said. So you can go ahead and use the equations and the text from ChatGPT. And then say, as a bonus, it would also be interesting if the predictive results is some aspect of explainability to it, because then you can tell the user, hey, it's not going to get it right, and here's why. So the data set is available on GitHub, but if that's if you don't want to write down that link, and I'll make sure Andreas posts this somewhere on his webpage, at neurosymbolic.asu.edu, we have a tab at the top now for the ChatGPT MWP challenge that has the instructions I showed on the slide, link to the GitHub page and all that. And if you're interested as well, we've also set up this YouTube channel on neurosymbolic stuff if you care about that. So am I good on time?
Yeah, fantastic.
Okay.
So thank you very much.